Hi there, welcome to this video on volume. First of all, let's consider exactly what volume is. So the volume of a solid shape is just the amount of space that's inside of it. It's measured in cubic units. This could be centimetres cubed or metres cubed. That would be entirely dependent on what the lengths are measured in. This is a centimetre cube example. That means it's a cube with dimensions 1 centimetre deep by 1 centimetre wide by 1 centimetre high. That has a volume of 1 centimetres cubed, and that's because 1 times 1 times 1 equals 1 centimetres cubed. You'll start to notice a lot of relationships with our cube numbers in this topic. Sometimes we can find the volume of a cuboid by just counting the number of cubes that fit into it. For instance, let's look at this example. I can see that there are 6 cubes that make up that top layer, and I know that there are 2 of them. 6 multiplied by 2 would give me a volume of 12 centimetre cubes, i.e. the volume is 12 centimetres cubed. Let's consider these questions then. If I wanted to find the volume of this solid prism, let's count the amount of cubes that I can see on that front face. So far I've got 5, there's 9, and there's 14. And I know it's a double layer prism. So I've got 14 on the front face and another 14 on the back. That would give me a volume of 28 centimetres cubed. Let's have a look at another question. What about this one? Again, let's count the cubes on the front face that I can see. I've got 3 along the top, 4, 5 makes the first T shape, but again, I can see it's double layered. So 5 along the front plus 5 on the back means it has a total volume of 10 centimetres cubed. What about this one? Let's consider that front face again. It has 5 running along the bottom with an additional 3 along the top. So that has a volume of 8 along the front, plus another layer of 8 on the back. That gives me a total volume of 16 centimetres cubed. And one last one for good luck. Count the amount of cubes on the front face and then tell me the total volume. So we have 4 along the bottom, plus 3 along the middle row, that takes us to 7, plus 2 along the top, that's 9. This time, there are 3 rows of that. So the total volume would be 9 along the front, 9 in the middle, plus 9 on the back, to give me a volume of 27 centimetres cubed. Sometimes it's not always possible to count the number of cubes in the cuboid to find the volume. If that's the case, then we use the formula. Volume of a cuboid is just length times by the width times by the height, as indicated on this example diagram. Let's see that in action then. Let's try and find the volume of these cuboids. For the first one then, it has the dimensions 6 by 3 by 4. So we just multiply them all together to find the total volume of that shape. It would be 72 centimetres cubed. Don't forget to put the units on. Pause the video then and have a go at the other 5 cuboids. When you're ready to go through the answers, press play. Number 2 would be found by doing 5 times 6 times 2 to give you 60 centimetres cubed. Number 3 is 5 times 4 times 3 to give you 60 centimetres cubed again. Number 4 is 5 times 3 times 7 to give you 105 centimetres cubed. Number 5 is 6 by 10 by 5 to give you 300 centimetres cubed. And finally, number 6 is 2 times 3 times 11 to give you 66 centimetres cubed. Try these quick questions then to finish off this small part of the topic. Calculate the volume of the cuboid with sides of length 4 cm, 5 cm and 6 cm. Simply multiplying all those dimensions together gives me a volume of 120 centimetres cubed. Be sure that you're choosing the one with the centimetres cubed unit and not the centimetres squared there. The correct answer is A. Calculate the volume of a cube with sides of length 3 centimetres. Again, multiplying the dimensions would give me a volume of 27 centimetres cubed. Calculate the total volume of this shape. Here it's almost a compound solid shape, so break it down into the two bits. You have a cube at the top and a cuboid at the bottom. To find the cuboid then, just do 10 times 6 times 4. To find the cube, do 4 times 4 times 4 and add those two bits together. Gives you a total volume of 304 cubic centimetres. If we know the volume of a cuboid then, we're able to calculate any missing lengths that we may not be given. For instance, if I know the total volume of this cuboid is 72 centimetres cubed, I know that one of the dimensions is 3, one of the dimensions is 4, and I need to find this missing one, it's entirely possible. Start by multiplying the dimensions we do know. 4 centimetres by 3. That gets me up to 12. Now I need to think, well, 12 times what would give me 72 centimetres cubed? That missing dimension then could be found by doing the opposite. 72 divided by 12. It means that the missing dimension then must be 6 centimetres. Try and find the missing dimensions in each of these cuboids. Think about the dimensions you already have and what it needs to be multiplied by to give you the total volume given within the cuboid. Pause the video and when you're ready, press play for the answers. Okay, let's go through those then. Number 1 has a missing dimension of 3 centimetres. Number 2 is 7 metres. Number 3 is 4 metres. Number 4 is 6 centimetres. Number 5 is 6 metres. And number 6 is 2.5 centimetres. Try these quick questions again to practice finding those missing dimensions. Multiplying the 2 by the 4 that were already given, we get 8 centimetres squared, which would then need to be multiplied by 5 centimetres to get the volume of 40. This cube and cuboid have the same volume. Can you work out what the value of x is? I can't do much with that cube just yet because I don't know what any of the side lengths are. So let's start with the cuboid. I can work out the volume of that. That would be 8 by 4 by 2. That gives me a total volume of 64 centimetres cubed. Well, 64 is a cube number. What number would you multiply by itself and itself again to get 64? Well done if you recognised it. That would mean the dimensions of the cube are 4 by 4 by 4. So 4 centimetres is the value of x. Let's then extend this knowledge onto volume of a prism. In the last video regarding surface area, we spoke about prism being a 3D shape with a constant cross-section. We specifically looked at triangular prisms, but there are more that exist. When I say a cross-section then, it's just the shape that runs at a constant throughout of that solid shape. Here is a hexagonal prism. It has a hexagonal face that runs at a constant throughout the prism. To find the volume of any prism then, we just take the area of that constant face and multiply it by how far back it goes, or how deep the shape is. I already know that the area of this hexagon is 25. That's indicated because it's got squared units. So all I really need to do then is multiply that area by the length of the prism, which is 10 centimetres. That means the volume of the prism is 250 centimetres cubed. What about where you're not given that area though? Well, you'd have to find it out first. Here I can see that that end cross-section is a triangle, so I need to find the area of the triangle at the end of the prism. I would do that by taking 4 multiplying by 3, base times height, and dividing it by 2. That would give me 6 centimetres squared. Once you have the area of that cross-section, you multiply it by how far back it goes, and that is this length here. The length of the prism is 6.5 centimetres. Multiplying them together then gives me a volume of 39 centimetres cubed. Try these quick questions. Here you've got a triangular prism. Find the area of the triangle and then multiply it by how far back it goes. To find the area of the triangle then, do 8 multiplied by the 3 for the perpendicular height and divide it by 2. It gives you 12. Then take that 12 and multiply it by how long the shape is, 10. Gives you a volume of 120 centimetres cubed. What about the volume of this trapezoidal prism? We didn't have to worry about finding the area of a trapezium, even though you would know how to do that, as it's already given to us. The area is 28.5. We just need to multiply that then by how far back it goes. If I do that, I get a volume of 265.05 centimetres cubed. There's one last special prism we'd be expected to work with, and it has a special name, a cylinder. It is a prism where the cross-section happens to be a circle. So to find the volume of a cylinder, you find the area of the circle, which we know to do by doing pi times r squared, and then times it by the height. Let's work out the volume of this cylinder then. First of all, let's do pi times the radius squared. Here, the radius is 6. When I do that, I'm then going to times it by how long the cylinder is, which is 12 centimetres. When I type that into my calculator, the first answer I'm going to get is in terms of pi. So it's going to give me 36 pi times by 12, which would be 432 pi. First of all then, let's change that into a decimal. That would be 1,357.17 centimetres cubed as a volume. In your answer, please make sure you're giving your answer in the terms that they want, either in terms of pi or as a rounded decimal. Try this final question for yourself. Give your answer in terms of pi, but we'll also explore the answer as a decimal as well. Okay, let's start off. We're going to do pi times r squared to find the area, so that would be pi times 6 squared, and then times it by the height or the length of the cylinder. In this case, that's 8. When I do that then, the first answer it gives me is 288 pi. So I can see that A is the correct answer here. Ideally though, I want that as a decimal as well. If I change it to a decimal, it would be 904.8 centimetres cubed. And there we have it. That's the end of our volume work. We've looked at the volume of cubes, cuboids, prisms, and cylinders. Now try all the practice resources to go with this topic. Thanks for watching.